Hi guys, today I'm going to talk about this problem from my first midterm exam. This question is asking for the normal stress in x direction, in y direction, and the shear stress. So this plate has has the stress of 70 megapascal acting uh, in slanted orientation, as well as the 150 megapascal acting horizontally. So to approach this problem, there are multiple methods to calculate all those stress components, but the easiest way is to use the force equilibrium equation. So the first step that I would do is to actually cut the plate and expose the element um, where the plate is being cut. So after you cut the plate, so this is the corner of the of the plate that is being cut. So since it's being cut, the stress element is being exposed, so that would be sigma xx in this orientation. Um, I would assume sigma xy in that orientation. There's also 70 megapascal in this orientation and 150 megapascal in that orientation. So by definition, sigma yy is the stress perpendicular to a plane. So when we focus on this stress component, so I'm sorry, I used the wrong color. So this is 70 megapascal. That's 30 degrees. So sigma yy is the stress perpendicular to the plane. So in other words, this is sigma yy, and sigma xy on the other hand is the stress along the plane. So in other words, this is sigma xy. So this is a rather easy problem because you will just have to split that 70 megapascal of stress into x and y direction pretty much to get the sigma yy and the shear stress. So let's just do it now. So sigma yy equals to 70 megapascal. So in this case, it would be sine 30 degrees, which is 35 megapascal. And then sigma xy would be 70 cos 30, which is 70 root 3 over 2, which is 35 root 3. And then in the beginning of the video, I mentioned about using the force equilibrium equation. So this is actually being used to calculate the normal stress in x direction. So sum of force in x direction equals 0. So keep in mind that the pressure equals to force divided by area. So since we are using the force equilibrium equation, we have to convert we have to use stress times the area to get the force. So sigma xx. Okay, before that, another thing to mention. So we assume this side, the area of this side to be A. What's this color? So in other words, this side, the area of that side would be A sine 30 degrees. degrees. And the area of, let me just use another color, of this side would be A cos 30 degrees. So let me just go back to the force equilibrium equation. So sigma xx times A sine 30 degrees would be the force on that surface in x direction. So since I assume left is negative, so I'm going to add a negative sign in front, and then plus 150 times A, and then people usually would forget the stress, the shear stress along this plane. So make sure not to forget that force acting on that plane. So minus what we have calculated for the shear stress acting on that plane would be 35 root 3 and then A cos 30 degrees. And then what we are going to do is to isolate sigma xx, and then after isolating sigma xx, you should get something like 195 megapascals. So the answer is here. So just use green to highlight the answers. So the answer is sigma yy equals to 35 megapascal, sigma xy equals to 35 root 3 megapascals, and sigma xx is 195 megapascals. Thanks for watching and have a good day.